Okay, so in the last class, I have shown the all types of problems by Frobenius method, and I told uh, that some problems you need to practice from the exercise. If you have tried already, then well, uh, otherwise try it. Okay, and you tell me, means is it enough for you whatever I have shown or did in the class, and or if you tell me that I need to do more problems from Frobenius method, then I can do also. Tell me, do I need to solve more problems from the exercise?
Sir, can you show one?
One problem. Okay,
Yes.
one problem I can show, but that may take the whole class, so whole time. No problem.
सर तो एग्जाम में कितने मार्क्स का आएगा?
10
ओके
means
में तो 6 मार्क्स का ही होता है ना?
means I'm talking about end sem. Sorry, mid sem. Mid sem, see, if they ask for only one solution, they may give 5. Means only y1. And if they ask for two solutions, means y1 and y2 both, then they may give 10. Okay. So 5.3, then 5.4, Bessel's equation, and I think it is the last chapter, last section in this chapter. Yes, so don't worry, we are at the end of this chapter. So it will not take actually more than 4 class. Okay.
Okay, sir.
Now you can tell me which problem I have to solve.
Sir, fifth.
Fifth one.
Yes.
Okay. Have you tried? Have you tried or not?
No, sir, not right.
Okay. I have shared my screen, right? You can see my screen.
Yes, sir.
Okay, so I'm doing problem number 5 from this exercise 5.3. What is the problem? X, Y, double dash, next, plus 2x plus 1 y dash, last term, x plus 1 y. Is it? Let me check again. So xy double dash 2x plus 1 y dash plus x plus 1 y is equal to 0. Okay. So here x is equal to 0 is a regular singular point. I can see that x is equal to 0 is a singular point, right? Because px, it is of the form something divided by x, qx also. So x is equal to 0 singular point. Now if you multiply px by x and qx by x square, both of them will be analytic, right?
Yes, sir.
So x is equal to 0 is a regular singular point. Therefore, we take y is equal to summation m0 to infinity am x to the power m plus r ba power series solution. Okay, provided a naught not equals to 0. So don't forget to write that a naught not equals to 0. Now y dash will be 0 to infinity m plus r am x to the power m plus r minus 1 y double dash m0 to infinity m plus r m plus r minus 1 am x to the power m plus r minus 2, right?
Yes, sir.
Now 1 can be written as, means I am multiplying these factors. Okay, a 2x plus 1 into y dash, so it is 2x into y dash plus y dash, and x plus 1 into y, so it is x into y plus y. Now 1 implies x y double dash plus 2x y dash plus y dash plus xy plus y is equal to 0. Now substituting y, substituting the series form, like y dash and y dash series. So substituting the series for y dash y double dash, we get to x into y double dash. Okay, so if you multiply y double dash by x, that power of x will change only, right? It will be x to the power m plus r minus 1. So summation m0 to infinity m plus r m plus r minus 1 am x to the power m plus r minus 1 after multiplying x. Now y dash into 2x, so you multiply y dash series by 2x, so it will be x to the power m plus r and 2 multiplied inside. So summation m0 to infinity 2 m plus r am x to the power m plus r. Next y dash, so substitute the series for y dash m0 to infinity m plus r am x to the power m plus r minus 1. Next xy. So multiply the series for y by x. So what will be the power of x to the power means what will be the power of x then if you
X
multiply
to the power m.
x to the power m plus r plus 1.
Okay, okay, yes, sir. Yeah, R plus.
We are multiplying y by x na, so it will be
Yes, sir.
am x to the power m plus r plus 1. So plus am x to the power m plus r plus 1, and lastly the series for y m 0 to infinity am x to the power m plus r is equal to 0. So there are 5 series. We have to sum of this series. So 2m plus r, 2 series for m plus r minus 1. Okay. So I can do one thing. Initially, I can add the series whose general term degree is same. Okay, means I can add this and this, right?
Yes, sir.
Also, I can add this and this, x to
Yes,
the
sir.
power n plus r, x to the power n plus r, and it is a different one. So overall, I can write it as a sum of T series. Look, so which implies now m 0 to infinity m plus r, m plus r minus 1 am, and in the third series it is m plus r am. So altogether have you all got it?
Yes,
Yes,
So I
sir.
sir.
have written this. I have taken
Yes, sir. X to power m plus r
this two
minus 1
series
is
together.
common. Yes.
Next I am taking these two series together. Okay. So it will be what? Plus m 0 to infinity uh, 2 into m plus r plus a plus 1 whole bracket am x to the power m plus r, right? And one more series left. It is m 0 to infinity am x to the power m plus r plus 1 is equal to 0. Now I have three series. So for the uniformity, I can convert this m plus r minus 1 to m plus r form, and this m plus r plus 1 to m plus r form. So for that, what I have to take as substitution? For the first series, you take m minus 1 is equal to
S.
s, right? So for the first series, m minus 1 is equal to s. Second series, m
M
is
is equal
equal
to
to
S.
third series,
M plus 1 is equal to
M plus 1 is equal to S, right? Because the power is M plus R plus 1. So if you take M plus 1 is equal to S, then it will be of the form S plus R. Now, accordingly, change the variables. So for the first, it will be summation. We have taken M minus 1 is equal to S. Okay. So if you put M is equal to 0, then S equals to
minus 1.
minus 1. So S will be minus 1 to infinity, and M is equal to S plus 1, right? For the first, M is equal to S plus 1. So S plus R plus 1 into S plus R. Actually, you see, if you take M plus R common from these two, it will be what? M plus R minus 1 plus 1. So it is not it M plus R whole square.
Yes, sir.
Think. Is not it
Yes, sir.
S
Yes, sir.
M
Yes.
plus R whole square? So M is equal to S plus 1. So
So it will
S
be S plus R plus 1 whole square.
whole square. Correct. So S plus R plus 1 whole square. A S plus 1 x to the power S plus R. And the second to easy, S0 to infinity, to it will be S plus R plus 1. And third, sorry, I missed A is x to the power S plus R. And for the third, I have taken M plus 1 is equal to S. So if you put M0, S1, right? For the third, M is equal to 0 means S1. So S1 to infinity, M is equal to S minus 1. So A S minus 1 x to the power S plus R is equal to 0. Am I correct?
Yes, sir.
Okay. Now, can I add these three series? No. So for that, you have to extract some terms. So where to extract? First of all, you fix the largest lower index. So S is equal to 1 is the largest lower index, right? So from the first series, how many terms I need to extract?
So 2.
2 for S is equal to minus 1 and for S is equal to
0.
0. So if you put S is equal to minus 1, it will be what? R square A naught x to the power
R minus 1.
R minus 1. And second term, for S is equal to 0, it will be R plus 1 whole square A1 x to the power R.
Yes.
And rest of the series can be written as S1 to infinity S plus R plus 1 whole square A S plus 1 x to the power S plus R. And for the next, you have to extract only one term for S is equal to 0. So for S is equal to 0, the term is 2R plus 1, then A naught x to the power r, right?
Yes.
And the rest of the series s 1 to infinity 2 into s plus r plus 1 as x to the power s plus r, and this as minus 1 x to the power s plus r is equal to 0. Look, up to that you have to take some time and need to do the calculation correctly. If you do some mistake in the middle somewhere, overall the things will be incorrect, right? So up to this you take your time, the rest of the things are simpler, simple thing. So see, uh, now I can write it as a single series. So it is r square. Is it enough space to write the next one? No, I'm writing the next slide. So r square a naught x to the power r minus 1 plus, look, there are two terms of x to the power r, right? This and this. So you can add this. It will be r plus 1 whole square a1 plus 2r plus 1 a naught whole into x to the power r, and rest of the series you can add. These three series you can add. So after adding, plus summation s 1 to infinity, so s plus r plus 1 whole square s plus r plus 1 whole square a s plus 1, next 2 into s plus r plus 1 s plus r plus 1 as, and lastly as minus 1, as minus 1. X to the power s plus r is equal to 0. Please check if there are there are any mistake
No, sir. No mistake.
from this line to next line. If there is a mistake in plus and minus also, then the whole thing will be changed. Okay, now you can equate the coefficient, right? So equating coefficients, we are getting r square a naught is equal to 0. We are getting r plus 1 whole square a1 plus 2r plus 1 into a naught is equal to 0, and the general degree term coefficient s plus r plus 1 whole square as plus 1 plus 2s plus 2r plus 1 into as plus as minus 1 is equal to 0. Okay, so first relation, it is called tell me the coefficient of lowest degree term is equal to 0 gives us
A not 0.
no, gives us initial equation. And already at the beginning I have assumed that a naught not equals to 0, so a naught cannot be 0, so r square is equal to 0, right? So 2 is the initial equation. So r square is equal to 0, right? The initial equation is r square is equal to 0 because first r square into a naught 0, a naught not equals to 0, then r square must be 0.
Yes, sir, yes, sir.
So that is the initial equation. Always I told that coefficient of lowest degree term is equals to 0 gives us the initial equation, and which is the main part of the Frobenius method. Okay.
Okay. So that means A naught is not equal to 0.
A naught not equals to 0 we have assumed initially
Yes, sir, yes, sir.
because
Got
of that, क्योंकि यहाँ से a naught तो always 0 आ जाएगा, तो नॉन जीरो सोल्यूशन के लिए we have to assume a naught not equals to 0. So what are the roots?
So 0, 0.
सर
हाँ
सर थोड़ा फिर से बता देंगे क्या, ये जो इंडिशियल इक्वेशन वाला समझ में नहीं आया.
look, have you understood how I got this equation number 2?
Yes sir, that I understood sir.
So I have simplified r square into a naught is equal to 0, right? So from here can I write r square is equal to 0?
Yes sir.
And that is the initial equation. Actually in that previous, in the last equation, in the last form of the series, the lowest degree term, it is the lowest degree term, right? R square a naught x to the power r minus 1, it is the lowest degree term. Do you agree? And it is the definition that coefficient of lowest degree term is equal to 0 gives us the initial equation. So equation number 2, it is nothing but the initial equation.
Okay sir.
Okay. And क्योंकि यहाँ पे here a naught is not equals to 0, so r square is equal to 0. That is the final form of initial equation. Now you have to find the roots, and I got that 0 is a double root, means roots are repeated roots, right? So it is one case now when the roots are repeated. Actually the same roots we got in an example. Do you remember? 0, 0. So what is the case for a double root? Actually first solution it is obvious type, means there are only one and only method for the first root. So for r is equal to 0 I am fixing the first solution. Okay, for r is equal to 0 I am fixing the first solution y1. So how to fix it? Now look, apart from this equation 2, now there are no other use of this initial equation. Initial equation का use हो गया. Now we will use equation 3 and 4 to find the relation between the coefficients. Okay, so for r is equal to 0, now tell me what will be equation number 3. If you take r is equal to 0, then it is a1 plus a naught is equal to 0, right? I have put the value of r in equation number 3.
Yes, sir.
Then it is a1 plus a naught, na? Yes. Tell me any doubt?
No, sir.
Okay, now put r is equal to 0 in equation number 4. It will give us the recurrence relation. Okay, so it is the recurrence relation. Equation number 4 is the recurrence relation which contains r. Now if we put the value of r, that is a particular means recurrence relation. Okay, so for r is equal to 0, the recurrence relation will be s plus 1 whole square as plus 1 next term will be 2s plus 1 as next plus as minus 1. So it is the recurrence relation. Now you can simplify it. So from here I can write as plus 1 is equal to what? 2s plus 1 into as plus as minus 1, actually there is a minus, divided by s plus 1 whole square. Can I write it? Tell me.
Yes.
So here s is starting from, in that summation you see s is from 1 to infinity. So s, it is starting from 1. Now from the first relation I can write a1 is equal to minus a0. Okay, so I got a1
Yes,
in
sir.
terms of a0. Now for the others a2, a3, a4, a5, you have to use this recurrence relation. So from on that recurrence relation you put s is equal to 1. You put s is equal to 1. Then it will be a2. So a2 is equal to 3a1 plus a0, right?
Yes, sir.
3a1 plus a0
By 2 square.
divided by 2 square means 4. Now you can write a1 in terms of a0 minus a0. So minus 3a0 plus a0 divided by 4. So it is minus, okay, one minus is there now. So it will be what? a0 by 2, right? a0 by 2. Any doubt?
No, sir.
s is equal to 2. For s is equal to 2,
सर वो जो बाहर माइनस है वो होल माइनस होगा ना?
हाँ होल माइनस है ना, ये होल माइनस है.
सर तो फिर सर वो माइनस ए नॉट बाई टू
यस
होगा.
सर, माइनस ए नॉट होगा. माइनस
Minus
3 ए नॉट माइनस ए नॉट.
no. You
Sir,
see,
A1 equals to minus
a1 is equal to minus a0 I have put.
ओह यस सर.
ओके
a1
ओके
is equal to minus a0. So minus 3 a0. I have not multiplied that minus. Okay. Minus 3 a0 plus a0. So it will be minus 2 a0 and minus plus 2 a0. Is it clear to you or not?
यस सर.
So A3 is equal to minus, I have put S is equal to 2. Okay, so 2 to the 4, 5. 5 A2 plus A1 divided by 9. So minus 5 into A0 divided by 2 minus A0 whole divided by 9. तो क्या हो जाएगा? It will be
minus A0 by 6.
minus A0 by 6.
Yes.
So 5 minus 2 means 3 by 2. So 3 by 2 divided by 9. So it is 1 by 6. Yes. So minus A0 divided by 6. So you can see it is coming in factorial form. It is factorial 2. It is factorial 3. Now let us see the next one to confirm it whether it is exactly coming in factorial form or not. If for s is equal to 3, if it is A0 by 24, okay, then I will be assured that it is coming in factorial form. So for s is equal to 3, it is A4 minus, the form is 2s plus 1 to 7 A3 plus A2 divided by 16, right? So minus 7 A3 means minus A0 by 6 plus A2 means A0 divided by 2 whole divided by 16. Simplify it. So minus 7 A0 and plus 3. So minus 4 A0. Minus 4 A0 by 6. Minus 4 A0 divided by 6.
So it is minus A0 by 24.
1 by 16. Yes. So minus and this minus. So all over it is plus. A0 by 24. Right? All over it will be plus, na?
Yes, sir.
This. So we got a specific form. Now you write what is the first solution. Therefore, I am writing y1x. The form of the solution is x to the power r summation am x to the power m, right? So y1x will be x to the power r, means x to the power 0. Then a0, a1x, a2x square, a3x cube, a4x to the power 4, and so on. Now you substitute the coefficients. So x to the power 0 means 1. Do you get it? How means how I have written this y1x?
Sir, explain.
Okay, actually initially what I had taken as a solution, y is equal to summation m0 to infinity am x to the power m plus r be a power series solution, right?
Yes, sir.
Yes, sir.
That is the basic solution which I have assumed. So in that, actually in that formula I am putting the value. So it is what? It is y x to the power r summation m0 to infinity am x to the power m. Now if you split this series, it will be what? Do you get it?
सर थोड़ा फिर से बोल दीजिए सर, समझ नहीं पा रहे हैं.
Look, the initial series, it is m0 to infinity am x to the power m plus r.
Yes sir.
Or you can write x to the power r into m0 to infinity am x to the power m.
Yes,
Can I
sir.
write this? Can I write this?
Yes,
Yes,
sir.
yes, sir.
Now, if you split this series term wise, then can I write this?
Yes, sir. Yes, sir. Yes, sir.
So, lastly, I had taken this form. Actually, why I have taken this form? I have to substitute. Na? At last, I have to substitute the coefficients. That is why I am expanding. I am expanding the series. Fine.
Yes, sir. Yes, sir.
In power series solution also, I had taken this type. Lastly, whenever I wrote the solution, I have expanded the sum and then I put the coefficient values. So in our case, here r is 0, right? So x to the power r को 0, x to the power 0, and rest a naught plus a1, x, a2, x square, a3, x cube, and so on. Now substitute the coefficients. So x to the power 0 is 1. Now a naught remains unchanged. A1 is what? Minus a naught.
Minus A.
A2, A3. I am writing in factorial form. Okay, because A2 is actually a naught by 2. That means a naught by factorial 2. A3 is minus a naught by 6. So it is a naught by factorial 3. Is it clear to you?
So what happened in the second step?
I have put these values A2, A3, A4,
Oh, okay.
A1.
Yes, sir.
Okay. यही है ना? After putting the values of
Yes, sir. Yes, sir.
A1, A2, A3, A4.
सर अगर हम फैक्टोरियल फॉर्म में नहीं लिख कर ऐसे ही लिख दे मतलब
That will be also okay. Actually, to find the second solution, I need to write the series in known form. Otherwise, I cannot find the second solution. Okay.
Yes, yes.
In the previous class, I told if we did not get any specific form, known form, or closed form of the series, then we cannot find the second solution. So to write in means that closed form, I am writing in factorial notation. Actually, it is a known series. You can see it is, if you take a naught common, 1 minus x plus x square by factorial 2 minus x cube by factorial 3 plus x to the power 4 by factorial 4 and so on. It is a series for which function?
Sir, is it e to the power minus x?
Yes, it is e to the power minus x. So to represent this series as a known function, I have written in factorial form. Okay, but if in the question it is asked find one solution, then you can stop here. No need to write the closed form. But if they ask find the second solution also, for that you need to know the closed form of the series. Okay. So here I am assuming a naught 1. So y1 will be e to the power minus x. Okay. So to find y2, we apply what? Look, when we apply the reduction of order method, if the roots are double root, means that is depending on the roots of indicial equation, right? If the roots are double root or if the roots are differing by integer, in that case we will use the reduction of order technique to find second solution. That I told now. Is it clear to you? when
Yes, sir.
when we need to apply this reduction of order technique?
Yes, sir.
Now, according to the reduction of order, the formula is y2 is equal to u into y1, where u is equal to, what is the formula? 1 by y1 square e to the power minus integration px dx. Now, 1 by y1 means e to the power minus x, so e to the power minus 2x y1 square, and e to the power minus, what is px? For px you have to go to the initial ODE. So according to the ODE, what is px? 2x plus 1 by x, right?
Yes, sir.
Do you get it how I am fixing px? For
Yes,
that, you
sir.
have to compare the ODE with that form, y double dash px into y dash plus qx into y. So what is px? Here you see that y double
2x
dash is
plus 1 by x.
yes, y double dash is multiplied with x. So you have to divide the whole equation by x. Therefore, px will be 2x plus 1 by x. So there I will put 2x plus 1 divided by x dx, whole dx and dx. Now you first of all simplify that integration. Don't put any arbitrary constant. Okay, you simplify that integration and ultimately tell me what is the value of this integration. You tell me. I am giving you time. In the meantime, I am taking attendance. You solve it. What is the value of u? Tell me.
Sir, it is LNX.
ln x.
Yes, sir.
Okay. Match this with your friends. Roll number 742,
Yes, sir.
44, 45,
Present, sir.
46, 47,
Present, sir.
48, 49,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
okay, 50, 55,
Present, sir.
56, 58,
Present, sir.
61,
Present, sir.
63, 64,
Present, sir.
65,
Present, sir.
66,
Yes, sir.
67,
Present, sir.
70,
Present, sir.
71,
Present, sir.